Hey, what's going on, guys? Let's look at this problem right here. Here this question is asking a ring placed along y square plus z square is equal to 4, x is equal to 0 carries a uniform charge of 5 microcoulomb per meter. Find d at P300. So first they are asking for the d mean they are asking for the flux density. Now before we go and calculate this one, let's go ahead and draw the diagram. Here they have mentioned the equation of the ring is y square plus z square is equal to 4. It means this is a circle with radius 2. So we are going to have something like this, and if you pick up a point somewhere here, let's say this is our point right here, let's call this one dl. So there's going to be an electric field due to this one, but let's go ahead and draw the xyz axis first. So in the middle we are going to have, okay, let's say this is our x. Let's draw 3 axis first. Let's say this is our x-axis, let's say this is our z-axis, let's say this is our y-axis. So if I pick up a point right here and the radius is going to be 2, since the equation of the equation of the circle is y square plus c square is equal to 4, the radius is going to be 2, and there's going to be an electric field due to this one, this point right here. That's going to look like something like this. We are going to have an electric field going through this way, right? But it's going to have two components. It's going to have x component and a y component. Actually x component and rho component. So let's say this is our x component and this is going to be rho component. So let's say this is dE, charge due to this small portion, and that's going to have two components. This is dEx and this is going to be dE rho. Okay, so this is how the diagram is going to look like. Now we are trying to find the d. To find the d, there's an equation for that, that's given by integral rho L dl r minus r prime divided by 4 phi r minus r prime cube. So this is the equation to find out the flux density. Okay, here rho L is the line charge and dl is the differential length. Also we can write dl in terms of rho d phi. Okay, if we write, and also we can write like that, and r minus r prime can be calculated using this formula. Since we have the point that's given 300, we are trying to find this density, flux density at 300. So we are going to use that one 300, and we have to subtract that one from the origin, minus c. We had to origin subtract from this. So 000, and that's going to give us 3 in the x direction, because this is the only value we have right now. If you subtract, that's the only one left, so that's in the x direction, 3ax. Okay, also we can find out the magnitude, since we know that this is 2 and this point is 300, x is 3, right? So this is 3, this is 2, so we can calculate the magnitude of this r minus r prime using this one. Like, we are looking at this length, Pythagorean theorem, 2 square plus 3 square. Okay, so that's gonna be what? That's gonna give us 4 plus 9, 13. So this is what we have right now. Now we have this one, so let's go ahead and rewrite the equation in terms of d phi and rho. Okay, so finally we are going to get something like this. D is equal to rho L divided by 4 phi integral rho d phi. Since d phi is the only thing changing, this is going to be just a constant, so that's why we move this one to the front, d phi, and then instead of dl, we found out this is 3x, r minus r prime is 3ax, so rho d phi r minus r prime, r minus, so here we have the original r minus r prime, that's the one we are going to plug right here. We calculated that is equal to 3ax divided by 4 phi, and the magnitude of r minus r prime cube is given by square root of 13 cube, right? So this is what we got right now. Let's see how we can simplify this one. We know the rho L value, that's given here, 5 microcoulomb per meter. So 5 micro means 10 to the power minus 6 divided by 4 phi integral rho. Rho is equal to 2. This distance is a rho. Okay, that's 2. 2 times 3ax divided by 4 phi. Let's see. This 4 phi. There's no 4 phi here because I already moved that one to the front. So there's no 4 phi here. So this is going to be just square root of 13 square, right? Then we have to integrate respect to phi. Now, after we do the integration, we are going to left with, since this is a circle, the limits of integration is going to be 0 to 2 phi, right? So we are going to have something like this: 5 times 10 to the power minus 6 times 2 times 3ax divided by 4 phi times square root of 13 cube. Then this phi goes from 0 to 2 phi. After we simplify and solve for this one, finally you will end up with 0.32ax microcoulomb per meter square. So that's our final D value. Okay, now we have done with the first part. First part is asking for the D, so we calculated it. Now let's look at the second part. If let's note this first part answer somewhere because we are going to use that one later in the second one. D is equal to 0.32 ax microcoulomb per meter square. This is what we derived from the first one. Okay, now let's look at the second one. If two identical point charges Q are placed at 0, -30 and 0, 30 in addition to the ring, find the value of Q such that D is equal to 0 at P. Okay, so here we have 2 points given. Now let's go ahead and redraw the diagram in terms of these two point charges. Okay, let's get rid of this one. Okay, so here we are going to have a diagram. Okay, first we have a circle. Let's draw that one first, and then we have 2 point charges. But before I go for that, let's go ahead and draw our axes: x-axis, y-axis, and then z-axis. X, y, z, and the radius of the circle is 2. Okay, we are having 2 points. Okay, let's say this is the negative. We know that this is going to go from 2, and here we are going to have -2. So -3 means we are going to have somewhere here, one of the charges somewhere here, -300. So Q at -300 is going to be somewhere here. Actually 0, -30, right? Because this is in the y-axis. So this is 0, -30. 0, -30, and then we have another one, 0, +30. That's also in the y-axis, a little bit above than this. Q 0, 30. Now from this one we are going to have electric fields due to these two charges. So let's draw that one. It's going to be somewhere here, and from this one it's going to be somewhere here. So let's call both of them DE. Okay, DE. both of them has y component, dEy, okay. Write the flux due to the point charge. Okay, now let's look at the flux equation. dq is given by q r minus r prime divided by 4 phi r minus r prime cube. So this is the flux density due to the point charges. This is how we calculate this one. Okay, now let's go ahead and calculate r minus r prime and the magnitude. R minus r prime can be calculated using just simply subtracting this one from the other charge. So first we have 300, that's the first one. Then we have to subtract this given one from that. The given one is what? 0 minus 30, that's the first one. We have to do for both of them. Let's do for the first one first. So 0 minus 30, and that's going to give us 3ax, because 3 in the x direction, positive, and also minus minus, that's going to make the y also positive, so 3ay. So this is our r minus r prime for the first charge, and the magnitude of this one is going to be r minus r prime is equal to, this is 3, and this height is also 3, right? So this is 3, this is 3, 3 square plus 3 square, square root of 18. Okay, so this is the magnitude for the first one, and r minus r prime for the first one. Okay, now let's look at the second charge. Let's write it with a different color. So let's say r minus r prime for the second charge is going to be what? This is the same thing. First we put the previous one p, that is 300 minus, then the charge distance 0, for this one positive 3, 0, and if we subtract this one, we are going to get 3 in the x direction, but for this one this is negative 3y, so this one negative 3ay. Let's look at the magnitude, r minus r prime. The distance is going to be same because both of them, this is also 3, right, from here, and the height is 3, so 3 square plus 3 square, that's going to give us square root of 18. Okay, so this is the value for both. Now we have the both values, so we can go ahead and calculate our flux density. So we know that flux density equation is this. Now since we have 2 point charges, we are going to add them together. So D is going to be what? First one is Q times 3ax, this one 3ax plus 3ay divided by 4 phi, and the magnitude we figured out, that's square root of 18, that cube. This is the first one, and the second one is we found out that is 3x minus 3ay, so q times 3ax minus 3ay divided by 4 phi square root of 18 cube. Okay, and after you simplify, you are going to end up, see, this one, the final simplification is going to be q times 6ax, because y gonna cancel, 3ay minus 3ay, y is going to cancel, 3ax, 6 is going to add up, and we are going to have 6ax, because the denominator is same, so we can directly add them, right? So denominator is going to be just the same thing, 4 phi times square root of 18 cube. So this is what we have right now, but this is not the end. Here we have calculated the flux density due to the point charges, but here they are asking find the q value such that d is equal to 0 at p. Now we have to make the d is equal to 0. Okay, so to make the d is equal to 0, what we have to do is, previously we calculated what is the d is, so we have to make d plus this dq, both of them addition should be equal to 0 in order to get d is equal to 0. Okay, so we have to just do this thing. Okay, now we have to know, like, we have to note down this final expression in order to do that. So let's go note down this dq value. Dq we calculated, that is q times 6ax divided by 45 times square root of 18 cube. This is the second one. Okay, we calculated d and dq, so we can find out what is the q values. We have to find the q value of q such that d is equal to 0 at p. Now let's get rid of all of these things. Okay, let's continue. Okay, so we have this d and dq. Let's go ahead and add them together to 0.32 microcoulomb per meter square plus q times 6ax divided by 45 times square root of 18 cube. The unit is going to be same, microcoulomb. Let's avoid the units for now. Okay, so this is 0.32 and this is this one. Okay, let's go and see. This we have to equalize this one to 0. Now it's better to keep the microcoulomb expression as well. Okay, microcoulomb per meter square. Okay, let's go ahead and do the addition. So this one is q is equal to q times 6ax over 45 times square root of 18 cube is equal to, if I move this one to the other side, we are going to have negative 0.32. Since this is micro, we have to multiply this one by 10 to the power minus 6. Okay, we are interested in finding the q value. So if you rearrange for q, you are going to get something like this. You are going to have negative 45 times 0.32 times 10 to the power minus 6 times square root of 18 cube divided by 6ax. Okay, finally if you calculate this one, you are going to get negative 51.185 microcoulomb. So that's going to be the charge. Okay, so that's going to be the final answer for the second part. I hope this helps. Thanks for watching.